Axial pump. In axial flow pump, the fluid enter and discharge both axially. It does not utilize centrifugal force like just the centrifugal pump did. It makes use of the impeller blades that works just like rotor fan of helicopter. The pressure difference between the top and bottom surface of the blade causes the lift force on the blade. Axial flow pumps used in conditions that require very high flow rate and very low amount of air. They commonly can be found in power plant, act as circulating water pumps. They also can be found in chemical industry for circulating large amount of fluid inside the evaporators. In incidents like flood, they are useful to dewatering large amounts of water over the short distance. Axial flow pump usually consists of an impeller with a few numbers of blades. The pump design is in such a way that fluid inlet and outlet is axially. An electric motor driven the impeller inside the pump. As the liquid is pumped, very low head is produced because the axial conditions of the impeller blade. Axial flow pumps have performance characteristics that differ from other pump types. The curve of head versus capacity is much steeper than other centrifugal pumps. Even though at normal operating point they produce very low head. The zero flow head may have as much as 3 times the head at the pump's best efficiency point. The flow is decreased as the required horsepower increase, with the highest horsepower draw being at zero flow. Axial flow pump generate much lower head than other types of centrifugal pump and capable of generating very high flow rates. If you look at the close distance, there are some twists in the blade. According to writers Chengel and Chimbala, the writers of Fluid Mechanics book, the airfoil at a cross-section near the roots of the blade is at higher pitch angle than airfoil at a cross-section near the tips.
Hi, John here. In this video we're going to look at centrifugal pump impellers. We're going to look at all of the main components that make up an impeller. We're going to look at how the impeller works, and then we're going to look at different types of impeller designs and the pros and cons associated with those types of impellers. So here is our centrifugal pump. I'll do a little spin. You can see the exterior appearance here. And if we spin back the other way, we can see a cross-section of the pump as well. The impeller is housed within the volute casing, and the impeller is the rotating item that we're looking at now. Before we have a look at how the impeller works, let's go and have a look at the parts that make up an impeller. As you can see, we've got quite a spirally shape. This is the impeller viewed from the top. We've got a bore in the middle. That allows us to connect the shaft to the impeller, and the angular rotary motion from the shaft can then be transferred to the impeller. The items indicated now are called vanes, and the gaps between the vanes are known as channels. On the back side of the impeller is a base plate, and this plate is what they refer to as a shroud. It's possible for impellers to have 2, 1 or no shrouds. Let's just rotate back around the other side. The type of impeller we're looking at now is called a semi open impeller because it only has one shroud. There are two other designs of impeller, and these are referred to as closed or open. We're going to look at these different designs later in the video. Now that we know the names of all the impeller's main components, let's have a look at how exactly the impeller works. Well, the impeller's job is to change kinetic energy into pressure energy. So we're exchanging velocity for pressure. We use a prime mover, such as an electric motor, in order to rotate the impeller. The impeller rotates within a fluid, and as it does so, it creates a negative pressure around the impeller eye, which is located at the center of the impeller. This negative pressure draws the fluid into the impeller. Because the impeller is rotating, the fluid is thrown outwards radially due to the centrifugal force that's imparted on it from the impeller. Notice that each of the vanes has a gradually increasing gap between it and its neighbour. For example, we can see here that the gap is quite small, and when we get to the outer periphery, the gap has become quite large. This change in dimension